What do you think is the potential for Mars-based innovation to be helping with sustainability challenges specifically here on Earth? So would someone like to kick us off?
Yeah, we can start with the basics: power, water, air, right? All the Maslow's hierarchy of need, that bottom base. What do we send? What do we produce on site? You know, like a lot of the missions in space, you have to think about things in advance, years in advance when you think about Mars, right? And so, of course, there are certain things that we won't be able to think about. And people evolve over the two and a half, 3 years of the mission, right? Who you were 3 years ago is very different from who you are today. And we can't expect this, you know, anything different from the people going to Mars. So what are the tools we're going to put in place for them to get the things that they need at the quantity they need it, but also the change necessary for them to have fulfilling lives during these 3 years.
Mm-hmm. Great.
Another concrete example would be, in addition to power, ISRU, all of that, is habitats. So years ago, again, this gets at timelines, might have been a decade now, we ran a challenge called the Deep Space Habitation Challenge, the prize competition to engage the public. Architecture firms got engaged in that, as well as all sorts of different design build companies. And one of the winners of that competition, Icon, and it was for a Mars application, right? That competition was envisioning the ways that we would build Mars habitats in the future. One of the winners of that, Icon, actually is out of Austin, Texas, is now not only building kind of 3D printed low-cost housing here on Earth, actually right now, right, as a spin-off application, but they also were contracted by NASA to be involved in building the Chapea demonstration facility. They're involved in thinking about lunar habitation, kind of 3D printing and additive construction methodologies for the future, but habitation is kind of another area that already has had an immediate, from a design competition and a demonstration competition, large Centennial Challenge, $2 million Centennial Challenge, you know, having impact here on Earth.
Yeah, you all met Melody from Icon in the previous panel,
Great.
So brilliant. Anything else to add, Hunter?
Yeah, I mean, maybe a little bit of a different problem set or different way of thinking about sustainability, but economic sustainability, social sustainability, and almost like psychological sustainability is actually very important, I think, on Mars, and maybe not thought enough about. Economic specifically, we're not going to have cash on Mars. We're going to be in a digital economy. What's that economy going to look like? How are people going to transact? And then from a social perspective, are we going to have, you know, a singular government? Are we going to have sort of, you know, a democracy? What is the government structure, and how is that going to be navigated within the different cultures that are on Earth? And one of the best ways we can do this right now is through digital simulation. We can, one example is there's a game called EVE Online. It's been going on for 20 years, and it's basically a economic simulation with a lot of different political factions that have grouped up, and they're vying over limited resources in this massive space economy. And it's been studied on how people have bartered, interacted, basically, and also just how power is shifted around this game world over the course of this real-time simulation. So we actually took a lot of inspiration from EVE Online when designing our first game, and we're called Thrive on Mars because we really want to focus on the positive. And all the other Mars games are shooting aliens, you know, like not dying. Even almost every single movie on Mars is about how to not die. And the psychological issue there is that you're planting in people's heads that Mars is, you know, a very dangerous place that you don't want to go. And I think if we really want to make life multiplanetary, we need to make sure to reinforce the beautiful parts about it. And so we really focus a lot on design. We focus a lot on the experience, the cool things, you know, jumping 3 times, you know, higher. We have buggy races, you know, things that are interesting that get people excited about going to a planet that's completely different.
Garuth, anything to add? Oh, I'm sorry, Phnam.
Sorry. Yeah, there's a big elephant in the room when it comes to sending humans to Mars is food. We still don't have reliable solutions for that. One of the most common food that you find, aboard the ISS or space missions is freeze-dried food. So freeze-dried food is basically you remove about 96% of the water of certain food, you package it up, and then you rehydrate it just before eating. That can give you a shelf life of about 2 years, which makes it too short to go to Mars, right? And so I'm talking to some companies, one of them being in Finland, they're called Frost Dry, and they found a way to remove 99% of the water in food. Not only that, they're also able to keep the structure of the food, so when you rehydrate a raspberry or a steak or anything else, they actually look like fresh again. And what's great about that kind of technology is not only the fact that perhaps we can send that to Mars, but also that way of processing the food allows for it, in theory, to keep the food for up to 50 years. So if you think about the implications of that, that can mean end world hunger, right? So maybe that back and forth between using the extreme environment of Mars, of the moon, or anywhere else in space can actually accelerate the research and the development of solutions like this. And I feel like there's a solution for food, there's a solution for power, there's a solution for water, for clean air, for trash management. All those big problems that we have today that impact our climate can be accelerated because of Mars.